Hello friends, welcome to ASF Tutorials. This is Afnan Pasha. Now we are going to study about two load cases in a cantilever beam. For that we'll go to a model wizard window. Here we'll choose a 2D material. In this, under structural mechanics, we'll choose solid mechanics solid. Click add and add it to study. Now in this select study table, we'll just choose stationary and just press done. I'll just reset the layout. This is a material obtained, so I want to give my physical parameter, so I'll right click geometry and click Bezier polygon. For this Bezier polygon I have to make a polygon, so click add linear. In the second row enter 4 x-axis and y as 1. Again give add linear. In second row enter x as 4 and y as 3. Again press add linear. In x-axis enter x as 0 and y as 4. Again press add linear and then press close curve. Then press or click build all objects, so that our polygon is obtained. This is at point 0, 0, and this is point 4, 1, this is point 4, 3, and this is point 0, 4. This is a polygon. Now to this polygon we have to create a point. So for creating the point, I'll just right click geometry and press point, and I'll give point at x is equal to 0 and y equal to 2 and give build all objects, so that I got my point at x is equal to 0 and y equal to 2. Now after giving the point, I have to go under solid mechanics to give my thickness. So when I came to my solid mechanics, I just choose plane stress, and under thickness D I should choose 0.1 meter as my thickness. After taking the thickness, I should right click my material and choose blank material. For the blank material, I should choose my Young's modulus value as 210 GPa, and my Poisson's ratio as 0.3 and my density as 7000. Our material is ready. Now we have to go to the definitions for adding load group and constraint group. Right click definitions, click load group and label it as load group cavity and Ig gravity. Again right click definitions and choose load group. Here again type load group force and Ig force. Right click definitions. Now choose constraint group for load and gravity. Now load group right click and choose constraint group and type constraint group gravity and CG gravity. And right click definitions, again choose constraint group and type constraint group force and CG force. Now our load group and constraint groups are ready, so we'll give our physical parameters. Now since we are giving it for first load cases, in the first load case we'll first choose fixed constraint, and this fixed constraint is given by this first load at the right corner, and in constraint group we'll choose constraint group gravity. Again now we'll go to the domains. In domains we'll choose body load and we'll choose the whole body, and in load group we'll enter load group gravity. Now down this type of load defined as per unit area will select. Now under x is 0 and y is given by minus g underscore const star solid dot rho. We'll just type the equation. After typing the equation, this thing is finished. Now we'll do to the body load 2. For that thing, go under boundaries, take roller and fix the ruler to the first 2 points and choose it as constraint group force. Since both the gravity is over, now we'll do for force. Again go to boundaries, choose boundary load, because here force of 10 meganewton will be acting. So choose the load. In load group, choose load group force. Now here in x axis or in x column, place type 10 meganewton per meter and leave the y column as 0. We have finished our constraint groups and load groups. Since this center point is remaining, for this center point I'll go to points and choose fixed constraint and select that particular point. Now I'll just go to our mesh. In this, from normal to I'll select it to fine, and then I'll build my mesh. My fine mesh is built. Now I'll go to understudy, I'll go to stationary. In the stationary, understudy extensions, I'll tick define load cases. Here add 2 load cases. In that, rename first load case as load case gravity and tick IG gravity and CG gravity. In second column, enter load case force and tick IG force and CG force. After this, just right click on study and give compute. Our experiment is getting computed. Now this is the graph obtained for our surface von Mises stress. Since we require stress in different form, we required a normal stress and a shear stress. For that reason, right click this solid stress solid and rename it as normal stress. And click OK. Under normal stress, there is a surface column. Click the surface column. Then from this, click it and choose replace expression. This is the replace expression column. Under solid mechanics, go to stress gauge points. Under stress gauge points, go to stress tensor gauge point evaluation spatial. Under that, use solid GPX. Double click it to select. This equation has been selected and click plot. A new plot has been obtained. Now right click results and choose 2D plot group and rename it as shear stress. Under this load case, choose load case gravity. After choosing load case gravity, right click shear force under model builder window and click on surface. Under surface, click this replace expression. Under solid mechanics, go to stress gauge points. Under stress gauge point, on stress tensile gauge spatial, press solid.sgpxy. Double click to select. After double clicking it, you have to place the deformation. For placing the deformation, copy the deformation of normal stress and paste it on the deformation of shear stress. Then press plot. Now we have obtained the 2 plots. Here one is for normal stress and other one is for shear stress. When you press for normal stress, the minimum normal stress obtained is 1.17 into 10 power 6 Newton per meter square, and the maximum normal stress obtained is 1.02 into 10 power 7 Newton per meter square. When we go to shear stress, the minimum shear stress obtained is minus 2.8 into 10 power 6 Newton per meter square, and maximum shear stress obtained is plus 1.57 into 10 power 4 Newton per meter square. If you want to do point evaluation, like if I want to do point evaluation for normal stress, press anywhere on the graph so that for that particular x and y values you will get one evaluated stress. For shear stress also same thing you do. At particular points you will get the values. As you see this is minus 0.5, so my value is again in minus. So this is how we'll solve the problem, or we'll obtain the program for two load cases. I hope everyone has learned this, and if you guys have not yet subscribed to my channel, please do subscribe. If you want to see more videos in your notification, so just click the bell icon. Thank you guys, see you in the next video. Have a nice day. Bye.